Right. So yeah, we should both just have only like one presentation, but because like I think like there's still in time, there's still like we still have a lot of time. So like we would be ready if just like give you guys another presentation about like Polkadot as well. But like this topic is less technical and like more like about the evolution of computers from like a bare metal to like a Polkadot, like to the whole blockchain space. So yeah, so this workshop is called from personal computer to Polkadot, the ubiquitous computing engine. And yeah. So to introduce again, I'm from OpenGuild. My name is Tin, and I'm from OpenGuild. I'm developer relation lead of OpenGuild. So what is OpenGuild? So OpenGuild is a Web3 builder hub or developer hub for Polkadot enthusiasts in Southeast Asia region. And we mainly focus on Polkadot and how to onboard a new developer to the Polkadot ecosystem. So if you're interested in like working in Polkadot ecosystem, also like learning more about the blockchain technology in the Polkadot. So like just feel free to join OpenGuild at like openguild.wtf, and our activities mainly focus on like hosting events and also like doing R&D, like research development stuff to contribute back to the Polkadot ecosystem itself. Okay, so what is a computer? So this is a very basic question, right? So I think that all of us right now, like even in this room, like all the people sitting here, have their own computer. So our computer is a machine that can be programmed to automatically carry out sequences of arithmetic or logical components operations. So our computer is also a one kind of computing engine. It's not gonna receive the input called a computation work, and it's gonna return back the output to the user. So say like, if you want to do like any kind of like mathematics operations, you give it like 1 + 1, what is it? Then the computing engine is gonna return back like 2, something like that. So a history of computer and evolution of the computing engine. So back then we maybe like a few centuries ago we have like one very first like computing engine called Abacus, and I think like when you learn that in your like secondary school, or I think like maybe lower, then like you gotta might be like familiar with Abacus, and you can use this tool to like do some like mathematic operations. Then we have like a very first computer which is invented during the World War II or something, as I remember. This is called analytical engine, and you can call it a computer as well. Then the input as or a computation work, that we mentioned is called a punch card, which is a kind of input that we're gonna give the analytical engine, so that it can process and return the output for us. Back then, like the computer is not very smart compared to the computer right now. You can type in directly what you want, so that the computer can return it out. So back then, like you have a punch card, like have like a different hole that you can just punch, and then like give it as the computation work. And also we also have a very first like programmer called Ada Lovelace, and so like a programming language design to call after her about the evolution of the computing devices. So back then we have a vacuum tubes. Like in our computer we have a 0 and 1. It's a very like bare state, to define like, whether the state can be flipped or something. So like you have a vacuum tubes, which is like you have like the eligible the electricity go to the vacuum tube, and it's gonna flip up the vacuum tubes. So you have like a different vacuum tubes, maybe like 10,000. That's 10,000 vacuum tube to define the state of the 0 and 1. So let's say if you have, let me count, 256 bytes, it's going to be like, shit, I don't remember. But anyway, yeah, I think like you get my idea. And like we have a transistor. Transistor is more powerful because like it can process more states than the vacuum tube instead of like only the processor like 0 and 1. And then we have the iterated circuit, which can like store thousands of the transistor, or up to like billions of transistor on top of the iterated circuit, which is also like the state of like, which also like the state of the microchip that we have it right now. Okay, so now we have like more laws. So like every years, like the number of transistor is developed, is produced twice compared to the last year. And an observations that the number of transistors on the microchip roughly double every 2 years, where its cost is half over the same time frame. And by that way, like the chip is also have a limitation in scalability, because like right now, like if you want to scale out, if you want to scale up your computer, you have to like produce a better microchip, which means like you have like more and more transistor, but like the size of the microchip is always something like that. Even it have to become smaller, so that it can save space for something like a fan that help like to cooling a computer, because right now it have to do more work. You have like more transistor inside the machine, so it need a cooling system. That's mean like the chip scalability is gonna bring up some problem, like increasing the cost to meet the industry standard, difficulties in cooling the component, and also like shrinking the component to fit in the same size chip. And there's a very highly recommended book that I really like, which is called like Modern Computer Architecture and Organization. I think it's a very good book for anyone who wants to learn about like x86, ARM, or ISC architecture. Also, some hardware of the computer include the data storage. First of all, hard drive, solid state, write it, or we saw like SSD, and processing unit, the CPU. So what is the problem here? The problem is in the vertical scaling. So let's go back to the component. So as you see like right here, all these kind of component every year is have to like to bring up the new model, which like have more technological advancement. But in that way, it's just like basically scale up, and like the system cannot scale out, because like you only have one laptop. So even like if you want like more, if you want it like to process more like computations, then like you have to scale up, like your CPU have to scale up more, like your hard drive to store more data. So what's the solution to it? Anyway, like first we go to like this scalability variant first. Like we have like vertical scaling. I already mentioned, like if you want to like process more computation, you have to like do vertical scaling or increase in like processing more power. But on the other hand, like, you can also like distribute the computation to like all the computers, so that it can help like to process the computation. And you have like more computer to help you to do that. So what's the solution here? So in our traditional computing, or we have like cloud computing, right? And in cloud computing platform like AWS, you have like AWS like host like a few like thousand computers that can help you like to that it can like open up the computation to like all this kind of computer, and then like you have all the computer can share the responsibility of one single computer to process the computation. So cloud computing is the delivery of computing services, including like server, storage, database over the internet. Some advantages of the horizontal scaling over the vertical scaling. For example, like horizontal scaling, it depends on the number of infrastructure node distributed. Node and data center are globally distributed. Shares resources. Resources can be shared across multiple cloud instances and services. No hardware limitation. You don't need like minimum. You don't need like minimum hardware requirements to play like games on the cloud, for example. But for example, like here, you can say like the cloud computing platform, the AWS software service. You have like, all these type like relay service that are already built like EC2 or like S3 bucket. But then all these kind of services rely on like the one brand name, which is like AWS, and AWS in the end is still a middleman behind all these kind of cloud computing services. So it's distribute the computing, the computation, and it make like it have more computers to do like computing stuff. But on the other hand, like you still have like one central party behind all this kind of service, which is AWS. Like Google Cloud Platform, also like in the similar case, you have Google Cloud Platform, you have different services like identity and security, compute service, networking service, big data, very brilliant. But on the other hand, it's also rely on one brand name, which is Google. So the problem here is like the centralized company behind the cloud services. And now we get to like Polkadot, the next generation computer. So it's also like the end goal of Polkadot is to deliver a resilient machine for the Web2 space. That like it can like help to process and help to compute as many like digital services on a global scale as much as possible in the future. In like Polkadot, we have like one concept called block space. And block space is also the foundation of the Web3. It's not only like the concept that Polkadot trying to introduce, but it's also like the concept is used in like Ethereum, also in Solana as well. And what is block space? So block space, like you have a space in on the blockchain, and this block space this can be used for like storing more data, that is provide more bandwidth or like provide more computing power. And block space is distributed across the globe. And here like, you can see like in a decentralized network of Polkadot, then like you have like for example back in my country, Vietnam, like we also have one node in Vietnam, and we have like a few different nodes in like Europe. We also have a few nodes in Malaysia here, and have a few nodes in China, and this is like distributed across the whole globe, similar to like any other kinds of distributed system. But in this way, like all those nodes can be run by like any individual, not only relying on one central party. And I would love to introduce more or like the Polkadot 2.0 or Age of Time, which is like Polkadot at this stage. And it is introduced a new concept called like Age of Time. But before learning about it, we should learn about like Polkadot 1.0 or like a parachain centric. So we mentioned about parachain in the last presentation. And like here the relation is the demand change of the protocol, which is trying to like become a central hub of every other parachain. It's trying to like send the data back to the relation so that it can like use up the sensor stuff and then become a whole like global share space of the whole parachain network. And like we have like all these kind of parachain, which is like plug and play into the relay change, become a part network, and it become a super network. All these kind of parachain is all like sovereign blockchain, and it's just basically like cross communicate with other blockchains using like CM, and this relay chain will be the central hub, the state, and all the parachains can like observe and also like can mutate this state of the relay change. And Polkadot 2.0, I think like I missed one slide here, but like let me explain. So in the Polkadot 1.0 case, in the parachain, when you plug it into the relay chain, each parachain will be assigned for one execution core of the protocol. This core concept is similar to like the core that we have in the normal computer. For example, like my computer here, I have like 32 core or something, and that means that I can run like 32 parachains on my computer. And also that's also applied to the Polkadot case. But what's the problem? So when you want to apply the core of the Polkadot network, you have to know something called like a parachain ocean, which is a candlestick ocean, and you can like purchase a core and then like take a like 2 years 2-year lease to like use the computation power of the Polkadot protocol. And the problem is this doesn't bring the flexibility for the whole network, because like after, let's say like if I acquire the 2-year lease and like I no longer like have any customer to use my blockchain, then how can I off lease, right? And also because as I'm using this, like this year you doesn't do well, but next year you can do better. So like you want like the flexibility. This is a required for like running any kind of digital service. And on that way, like the Polkadot 2.0 is create the concept of age of time that allow a parachain owner can like parachain team like can like purchase the core and then share the core with other people. You can see right here like the different color here to represent like a different parachain running on the network. Yeah. So and you can see like the illustration right here to represent the Polkadot 1.0, which means like in the whole 2 years late, every block produced and on the one core can only be assigned to one parachain. On the other hand, we have an illustration right here That means like it can share like the code across other. The code can be shared across other your parachage. Like one code can be used by multiple different parachage. And all these kind of realizations for like the same, similar to this one. This one is Polkadot 1 this one is Polkadot 2 But you can see here like you can still like do purchase ocean to like buy one core for the 2 years lease. If you think like your business can sustain in the whole 2 years and you don't need like flexibility with something more secure, and then you don't have to care about like buying the core every single time. So in that way, you just like do the core one. You buy like the core one can be applied by one purchase team. But on the other hand, like you also have core 2, core 3, which is can be shared across the purchase network. And one core, one block can also like be shared with all the purchase as well. Not only like one block per core can be assigned to one purchase. Okay, so how do you pay for AWS like computing power? So as a user, when you use a service on Amazon Web Service, then like we use like any service managed by the Amazon Web Service, then we have like the cost we centralized, and every month we have to pay bill for them. And decentralized cost is defined, also like is decided by the Amazon Web Service itself, and like the user or the community have no control over the cost on the Amazon Web Service. So how do you pay for Polkadot computing power? So in the case of Polkadot computing power, let's imagine like the Polkadot protocol is here. We already introduced about the concept of block space, and then in the block space, we're gonna have like a content cell, and this content cell, the price of content are going to be defined and also be decided by the community, which is like something like a democracy stuff. Like everyone can have a power to vote for like what kind of the price of the content. That's all like defined by the whole like decentralized marketplace. Not only like relies on one central party like Amazon Web Service. Okay, so from personal computer to Polkadot, so we have like this storage. Now we have a decentralized storage, and we are already familiar with that. For example, like IBMS, hardware computing power to like distributed computing power, file system to decentralized file system, CPU core to Azure core time, thread to power tab, apps to app change. And you see like all the concepts that you already know about in the traditional computer is already like converted and just like converted like improved to become another concept for like the whole like decentralized distributed world. Okay, so let's say in Ethereum we have like smart contracts that you can roll up, and we already talked about like Polkadot, which have like concept of parachange. And here's like a sneak peek of Chain. I think the Chain is already announced recently. We already have a rate paper for Chain. But like in the Chain case, not only it can like execute a parachain, parachain becomes like one type of work service on the chain, and you can see that parachain right here. But it can also like execute a smart contract and a native ZK rollup, because like now chain become a semi-concurrent network. It's not only like a fully synchronous network like Solana. It's not only like a whole like a synchronous network like Polkadot, but it's a mix of them that make like everything better for the blockchain space. Okay, so I think that's pretty much like the whole workshop today. It would be really like if I can have more time to talk about the Jam later, but I think it's enough for the workshop today. And like if you want to learn more about all the concept of Polkadot, want to learn more about want to like kickstart your career in Polkadot, contribute to the Polkadot ecosystem, like feel free to learn and also like join more in the OpenGuild community and like OpenGuild.WTF. I think like we also have a QR code right here. Just scan it. You're gonna see like our link tree or something. Okay, so how to contribute to the OpenGuild community, also the Polkadot ecosystem. You can make like propose new idea, contribute to project, grow the community, and like join our workshop and event, like what you're joining right now. And the benefit of contribution is gonna be like mentored by the subject expert. We have like a pool of like the whole expert pool that like can help you like to learn more about substrate, and networking with like other developers, improve your technical skill, learn by like building open source software, free open source software, and also like more career opportunities for you like to join the Polkadot market. Okay. Okay, so if you're interested in OpenGuild, you can scan this QR code to join the OpenGuild community. And yeah, thank you for listening.